Good morning. Today we're going to talk about Math 101 and in particular Chapter 4, Section 4, Slope-Intercept form of a line equation. Alright, I'm sure you're familiar or somewhat familiar with the slope-intercept form of a line equation. It's the most useful and indeed the most used of line equation forms. And it takes the form y equals mx plus b. Well, notice a couple of things in this slope-intercept form. Y is solved for in terms of x and other constants. So typically you get y on one side of the equation all by itself. And notice the x multiplier is really the slope of the line. And that can be very useful to graph the line or to read off graphs of lines and get equations out of them. Somewhat similar, the b is the y-intercept, or technically the y-coordinate of the y-intercept. Hence the name slope-intercept, or really slope-y-intercept form. If we look at an equation, y equals 4x minus 6. This is indeed in the form y equals mx plus b. Well, if I ask you to spot the slope is of course 4. And if you want the y-intercept, again, by inspection, you can see the y-intercept is going to be minus 6. It's going to hit the y-axis at the y value of minus 6. Okay? All right, let's look at a couple of simple examples here. First, I want to look at a line equation. Let's say y equals 1/2 x plus 3. Let's make a table of values here. And just like in previous sections, I'm going to pick x values that are multiples of 2 so I can steer around any unpleasant fractions. If x is 0, well, this term drops away and I've just got y equals positive 3. Well, notice this is the y-intercept. And we already knew the y-intercept was 3 because of that constant plus 3 in slope-intercept form. All right, let's grind out these other two coordinates I'll need. Let's say, let me do some side work here. Y equals 1/2. I'm going to plug in x equals 2. Y equals 1/2 times 2 plus 3. Well, 2 times 1/2 is really 1, and 1 plus 3 is, of course, 4. So when x is 2, y is 4. Gives me another pair of coordinates on the line. And how about if x is minus 2, 1/2 times minus 2 plus 3. 1/2 times minus 2, well, that's going to be a negative 1. The 2's cross cancel, and a negative 1 appears on top. So I'll get minus 1 over 1. Well, I get y equals minus 1 plus 3, which is, of course, positive 2. So when x is minus 2, y is positive 2. Let me go ahead and graph this line. Hopefully we'll notice some things, especially with relating to the slope-intercept form. All right. Let me draw a set of axes here. All right. If x is minus 2, y is 2. So let me draw those points, those coordinates. Minus 2, positive 2 puts me about here. And I'll go ahead and label that coordinate. X is minus 2, y is 2. How about the y-intercept? If x is 0, y is 3. Well, if x is 0, you're on the y-axis. And y equals 3, I'll put up here. All right, if x is 2, y is 4. Let's see, 1, 2. X is 2, y is 4. I'll say that puts me up here. And it looks reasonable to claim that all three are collinear points. All right, so I'll connect the dots. Label the line with the equation that generates it. All right. And I'll label these points. When x is 2, y is 4. When x is 0, y is positive 3. Notice the slope here. If I draw a slope triangle between these 2 points, my change in x is going to be, well, I go from 0, 3 to 2, 4. My change in x is going to be positive 2. And my change in y is going to be 1. Right? Y goes from 3 to 4. Right? So my ratio of rise to run is 1 over 2. My slope is indeed 1/2. Well, we already knew that because it's in slope-intercept form. And the y-intercept is, of course, positive 3, and we knew that also. All right, so again, slope-intercept form, very valuable when it comes to graphing lines, and indeed writing equations of lines when you're given certain information about those lines. All right, I want to do an example in the book. Let me get another sheet here. This is example 1 on page 264. Please look along because the textbook has a lot of graphing aids and visual aids that I can't replicate here. Example 1 on page 264. They give us a line in what we call standard form. Standard form is ax plus by equals c. In other words, a multiple of x plus a multiple of y equals some constant. Standard form. All right, the book asks us to write equation of line in slope-intercept form. And I'll abbreviate that as slope-int form, if that's all right. All right. Write line equation in slope-intercept form. Well, you've got to solve for y and clean up everything on the other side so you can visualize the slope and the y-intercept. All right, write equation in slope-intercept form, and then they ask us to state the slope and y-intercept. All right, kind of a two-part problem. All right, so I'll start here with this equation. Well, the first thing I'm going to need to do is solve for y. Do algebra things to both sides of the equation. Add, subtract, multiply, and divide. My goal being to isolate y, and then solve for y as needed. All right, first thing I'm going to do is add 3x to both sides. All right, will give me 4y equals 3x plus 8. Then I'm going to divide both sides by positive 4, both sides, all terms. All right, this cancels out the 4's on the left. Of course, I've got y equals. I can break up this sum over the common denominator, and I'll do that here. 3x over 4 plus 8 over 4. And of course, I can simplify this expression. I ran out of room here, so let me go to the side here. I'll just say y equals 3/4 x plus 2. 8 over 4 is 2, so I've simplified as much as I can on the right. This line is in slope-intercept form. Y equals mx plus b. Right? The slope here, the x coefficient, if it's in that form, is 3/4, and the y-intercept is 2. So slope of 3/4, y-intercept of 2. Okay? All right, let me scroll back up. All right, let's look at example 2 on page 264. Now, the book gives us two line equations. This is example 2a. There's really two parts to this example. All right, the first line equation they give us is 2x plus y equals 9. The second line equation they give us is 2y equals minus 4x plus 5. All right, and the book asks us then, are these lines parallel, perpendicular, or neither? All right, I suppose the easiest way to determine which of these three is the answer is to get the slopes. And I believe in this case, the easiest way to find the slopes is to convert the lines into slope-intercept form. So let me write that down. Convert to the form y equals mx plus b. In other words, solve for y and simplify. You'll then be able to read off the slope as the x coefficient. All right, so converting on this first one, I'm going to subtract 2x from both sides. I'll get y equals minus 2x plus 9. And right away I know the line here has a slope of minus 2. I'll then compare that to the slope of the second line. Well, here, to solve for y, I'll need to divide both sides by 2. All right. I can break up this sum over the common denominator to simplify. I get 4x minus 4x over 2 plus 5 over 2. And of course, minus 4 over 2 turns into a negative 2x. So y equals minus 2x plus 5 halves. The slope here is minus 2 as well. All right, so we can see that the slopes of these two lines are the same. Slopes equal. And if your slopes are equal, of course, you have parallel lines. So the final answer here would be parallel. Okay? All right, part B of this example 2 is similar. Again, the book gives us two lines. 3x minus 2y equals 7. And 6y plus 4x equals minus 6. Both of these lines are in standard form. All right, I'm going to convert to y equals mx plus b so I can grab the slopes, right? In this first line, I'm going to subtract 3x from both sides and then divide everything by negative 2. All terms, both sides. The minus 2's, of course, cancel on the left. I'll get y equals, well, if I break up that sum over the common denominator, I'll get this expression. Minus 3 over minus 2, of course, reduces to 3 halves, or 3 halves x, plus minus 7 halves. I'm not really concerned about the y-intercept here. In this problem, all I'm looking for is the slopes, and to compare the slopes. All right, so let me work now on the second line. I'm going to here subtract 4x from both sides. And then to solve for y, I would divide both sides by positive 6. I'll get y equals, on the left-hand side, minus 4x over 6 minus 6 over 6. Well, the x multiplier reduces to a minus 2/3, so I get minus 2/3 x minus 1, of course. 6 over 6 is 1. And for this second line, I get my slope as minus 2/3. All right, now these slopes are negative reciprocals. Write that down. They are reciprocals. They are opposite reciprocals of each other, or negative reciprocals. So let me write that down. Negative reciprocal slopes implies perpendicular lines, or just perp simply, okay? All right, so we can use slope-intercept form to spot slopes and determine things about lines given some characteristics. Let's take a look at another use of slope-intercept forms. We can use the slope-intercept form to graph line equations. So I'll write this next subtopic as graphing line equations using slopes and y-intercepts. Very useful tool in really making quick work of graphing some lines. Let's look at example 3 on page 265. They ask us to graph this line, minus 3x plus 4y equals 8. Again, this line is in standard form. Well, if we convert the line equation into y equals mx plus b layout, I can then spot the slope and the y-intercept by inspection. All right, let me go ahead and do that. I'm going to add 3x to both sides to start. Again, my goal is to convert here. All right, so 4y equals 3x plus 8. And then I'll divide both sides, all terms, by 4. I get y equals 3/4 x plus, let's see, 8/4, of course, 2. All right, so my slope, of course, is 3/4, and my y-intercept is 2. What I can do is use this information to graph the line equation. What I'm going to do is start at the y-intercept of 2, all right, if my y-intercept is 2, that means I hit the y-axis at 0, 2. And if my slope is 3/4, what I can do is draw, again, a slope triangle and say, well, if you've got a slope of 3/4, that means I've got a rise of 3 for a run of 4. So if I go 4 units in a positive x direction and then go up 3 units in a positive y direction, I can spot another point on the line, could I not? If this point, this first point we had the coordinates 0, 2, because that was the y-intercept, our new point would have the coordinates, well, x goes up by 4, y goes up by 3 according to the slope. All right, so if x goes up by 4, we go from 0 to 4 in our x coordinates. If y goes up by 3, y goes from 2 to 5. All right? So we get another legitimate point on this line besides the one we were given, and we can easily graph the line. Notice we did not need a table of values here. We used instead the slope and the y-intercept. And don't forget to graph or label the line with the equation that generates it, minus 3x plus 4y equals 8. You can label these with either line equation. I'm going to pick the second one because it's already in slope-intercept form. Y equals 3/4 x plus 2. All right. All right, we can also use the slope-intercept form to determine equations of lines that are already graphed for us, kind of working things backwards. All right, let's try to apply slope-intercept form in another scenario. Here we're going to use slope-intercept form to determine equation of a graphed line. In other words, the line is already graphed for us, and we can use the information from the graph to determine the slope and the y-intercept, and with those two things we can then write down the line equation. All right. All right, the book gives us a graphed line in example 5 on page 266. All right, let's go ahead and look at that line. Yeah, please turn there. The book, of course, the book's graph is much better than the one I can present here. I'll do my best. All right, the book gives us a kind of a downward sloping line, certainly a decreasing line. And if you'll notice, there are two coordinates on that point, on that line, that are labeled with dots. And I'll draw one of them and the other as well. And they are conveniently placed at grid intersections, and one of them is even at the y-intercept, so that should tell us something. 1, 2, 3, 4, 5. All right, so I'm exaggerating this. You can see it in the book. The two of the points on the line are labeled with big dots, conveniently placed at grid intersections so you can read off the coordinates. This point up here, it has coordinates, well, when x is -2, y is +1. And this point right here, well, it's the y-intercept, right? When x is 0, you are a y-intercept, and the y-coordinate here is -5. All right, so if I'm going to look to determine the equation of a graphed line, well, I'm going to want to get it in slope-intercept form, of course. Y equals mx plus b. We already know the y-intercept is -5, do we not? So y equals mx minus 5, and all we need to do now is to determine the slope. Well, let me connect the dots here. All right, I'm going to draw a slope triangle between these 2 points and see if I can determine the change in y over the change in x, the rise over the run. All right, looks like if I go from this point to this point, breaking up the path into a horizontal and vertical components, looks like the travel to the right is a +2 and a positive x direction. Similarly, if I look at the negative, or the vertical distance between these 2 points, I go from, let's see, y equals +1 to y equals -5. I go down 6, do I not? From +1 to -5. All right, so my slope is then going to be my rise over run. My rise here is -6. Negative rise means you're going down, right? And my run is +2, so my slope on this line is, of course, -3. So my final answer, all I need to do is then substitute that slope of -3 for m, and final answer y equals -3x minus 5. Okay? Let's do another somewhat similar example. We can also use slope-intercept form in another way. So let me see, use slope-intercept form to write the equation of a line through the point 4, 2 with a slope of 5. Now here you're not given a graph, but you are given information about the line in writing. You know the line is going to go through this point, and you know the slope of the line is got to be 5. All right? What I can do is, well, I can start to write my line equation. I know if the slope is 5, my x multiplier has to be 5 in slope-intercept form, right? So I know my line is going to look like this, y equals 5x plus b. I don't know the y-intercept. All right, how am I going to find the y-intercept? Well, I know this line goes through this point, what I'm going to do is plug in the x and y values given and then solve for the unknown y-intercept. So y is 2 in this point when x is 4. So plug in 4 and 2 for x and y respectively, and then I can solve for the unknown y-intercept. So 2 equals 5 times 4 is 20, and if I subtract 20 from both sides, b equals negative 18. So my final answer is going to be here, y equals 5x minus 18. This line must go through 4, 2, and indeed does have a slope of 5. All right, let's do some more examples of using slope-intercept form. Next one I want to do is example 8 on page 268. And write equation of line through the point 6, negative 2 with a slope of 2/3. And I'll say further, be sure write your answer in slope-intercept form. In other words, in the form y equals mx plus b. All right, again, similar to the last one, I know the slope is 2/3. Right away, I know my line is going to look like this. But I don't know the y-intercept. All right, but what I can do is plug in these x and y values that I do know. When y is minus 2, x must be 6, and I can then solve for the unknown y-intercept. All right, 3 cross cancels into 6 twice. 2 times 2 is 4, so I get minus 2 equals 4 plus b, and subtracting 4 from both sides, I get b equals negative 6. Not so bad. So y equals 2/3 x minus 6 is my final answer. Right? Line through a point with a given slope. All right, let's look at example 9. I think I got enough room. Example 9 on page 269, another right equation of a line question. Let me write it down. Right equation of line through. And here you're given 2 points. Minus 1, 3 and minus 5, 1. All right, so this is certainly different than all the other examples we did today. Well, let's think about this for a minute. What do we need? We need to, well, again, I'm going to say write and I'll say answer. Hang on. Be sure your answer is in slope-intercept form. And I'll say this, let me write it down. Answer in slope-intercept form. In other words, the form, of course, y equals something times x plus something, right? Well, we need 2 things to write a line equation in slope-intercept form. Of course, we need the slope and the y-intercept, right? We are given neither, but we can find them pretty easily. Remember, if I'm given 2 points on a line, I can find the slope according to my formula y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are any 2 points on the line. All right, so I'm going to let this point be x2, y2, and the other point be x1, y1. So y1, y2 minus y1 over x2 minus x1. Be careful of the double negatives and the signs. All right, so 1 minus 3 is negative 2. Minus 5 minus minus 1 is negative 4. All right, so it looks like my slope is going to be 1/2. All right, so I'm going to write my line equation with a known slope now. All right, so I know my line is going to look like this, but I don't know the y-intercept. And I'll find the y-intercept like I did in the last two examples. I can plug in either coordinates, either pair of coordinates here into the line equation for y and x respectively, and then use that information to solve for the unknown y-intercept. I'm going to pick this point here to plug in x and y. So when y is 3, x has got to be -1, and b is still unknown. Well, I'll get 3 equals 1/2 times -1 is -1/2. And of course, I'll need to add 1/2 to both sides. 3 plus 1/2 equals b. And of course, 3 is 6/2. Plus 1/2 will then give me 7/2. So my final answer is going to be here, y equals 1/2 x plus 7/2. Final answer. Okay? All right, one more I want to talk about today. Last one, another use of slope-intercept form is in graphing using the x and y intercepts. All right, let me get another screen. All right, here we go. This is example 10 on page 271. I think it's the last example for this section. They ask us to graph 3x minus 2y equals 8 using the x and y intercepts. All right, well, what we can do here is set up a table of values and say, well, for the x-intercept, I'll let y be 0 and solve for x. And for the x-intercept, for the y-intercept, I'll let x be 0 and solve for y. All right, so let me go ahead and do that. To find the x-intercept, I'll let y be 0. So let me plug in y equals 0. And I get 3x minus 2 times 0 equals 8. And of course, now I can solve for x pretty easily. So 3x equals 8, because 2 times 0 is, of course, 0. And x equals 8/3. So it's a little cumbersome, but we'll have to deal with it. Our x-intercept is a fraction. So let me rewrite this table of values now. If y is 0, we know x must be 8/3. And we'll graph that as best we can. All right, let me find now the y-intercept. All right, to find the y-intercept, you let x be 0. And solve for y. All right, so I'll plug in x equals 0, leave y alone, and solve for y. Well, of course, 3 times 0 reduces to 0. I get minus 2y then equals 8. Dividing by -2, now I get y equals -4. So when x is 0, y is -4. Now I claim I have enough information to graph this line now. I don't really need the slope. So let me go ahead and draw a pair of axes here. All right. Y-axis, x-axis, all right, Well, if x is 0, y is minus 4. That's the y-intercept. So I hit the y-axis at the coordinate minus 4, or 0, comma, minus 4. Well, that's 1 point on the line. How about here? If y is 0, x is 8/3. Now let's think for a minute. If y is 0, you're on the x-axis. 8/3 is really 2 2/3. I guess I could say it's a third of the way, or actually 2/3 of the way, between 2 and 3. I'm going to draw it right here, maybe exaggerating a bit for demonstration purposes. Let me go ahead and label the line, or these points. If x is 0, y is minus 4. And if y is 0, x is positive 8/3, 2 2/3, right? All right, I'll go ahead and connect the dots, indicating the line with all its points going off to forever in both directions, and of course labeling the line with the equation that generated it, 3x minus 2y equals 8. All right, this concludes section 4.4, slope-intercept form.